Welcome to our second lesson on solving systems by the elimination method. And this lesson is pretty much just going to consist of two more examples where we go through these steps, and I want to show you the different variations and ways that you can approach problem solving with this. Hopefully you're writing them down or you're taking pictures and copying them into your notebook, because when you're doing your own, one of the best things to look back at is an example problem so you can see what I did. So this next one, let me title it, this is example 3. Okay, and so this one is 2y plus, I can't read my own writing, 2y equals 7x minus 4, and x plus 2y equals 12. Now, what makes this one more challenging is because the things are not lined up. So if you think back to our steps from last class, the first thing we need to do is make sure that our x's and our y's and our equal sign and our constants are all lined up. And they often are. Like, you will often see them lined up. But sometimes you need to do a little bit of reshuffling in order to get them lined up. And there's no way that you have to have these lined up. You can move the 7x over here to the other side and try to line that up with the x. You could, that's probably the best thing you could do. Trying to think what else you could do there. That's probably the best thing you could do. Oh, you could move your x. You could subtract x from both sides and move it over there. You know what? Let's do that just for fun. All right, so here I have a y, an equal sign, an x, and a constant. So on this bottom one, I'm going to try to get a y, an equal sign, an x, and then the constant, which means I don't want the x over here. So to begin this, I'm going to start by subtracting x from both sides. If I subtract x, x minus x is 0. And then 12, you can't do 12 minus x. Those are not like terms. Now it's almost lined up. It's a little bit out of order. So remember, my 8th grade math teacher never let us write minus, subtraction. He always made us write plus negative. Always made us write plus negative. So while that seems like a little bit of extra writing, it does remind you that if you want to switch the order, that the negative comes with the x. So, and then the 12 stays positive. So remember that when you're switching the order, if the 12 was positive, the 12 needs to stay positive. If the x was negative, the x needs to stay negative. Now I have my two equations and I have them lined up okay. So let's go through this. We have this top equation, I'm going to rewrite this over here in my purple. So 2y equals 7x minus 4. And now I've taken this equation and I've just rewritten it a little bit. And I'm going to write that right underneath it. So 2y equals negative x plus 12. So now I have everything lined up, and I am just trying to demonstrate that you don't have to have them lined up in a particular way. There's no magical order, just as long as your y's, your equal sign, your x's, and your constants are lined up. Now we get to that step that requires you to think. This actually requires some thinking here. Which variable do you want to eliminate? There's no right answer. There's no wrong answer, I should say. There is a right answer. They're both right. There's no wrong answer. You can say, I would like to eliminate the y, or you could say, I would like to eliminate the x. Remember what you're going for, though. You want plus and minus of the same thing. I'll come over here and just kind of remind you, you're looking for something like that. So that when you add them, one of the, it's going to cancel out. That's what you're looking for. If you pick the y, that is a good choice because you have the same number. You have a 2 and you have a 2, and that's nice to see the 2 and the 2. What's not great about this one is that they're not opposites. So if you added them, you'd have 2y plus 2y, and you would get 4y, and it wouldn't cancel out. So that's got a good choice thing and something that's not as good. If you pick the x is a good choice because you have a positive and you have a negative. And you know that that's what you're looking for. You're looking for a positive and a negative of the same thing. The reason this is not a great choice is because you don't have the same number. You have a 7 and you have a -1 down on the second one. Either X or Y is fine. You just have to decide. So when I do this in class and for my live lessons that I'm doing for my live classes, I will probably just ask the class, which one do you want to get rid of? So let's just say somebody says, let's get rid of the Y. Okay, so I'm going to copy this over on the next page. Okay, so we have decided that we are going to try to eliminate the Y. Now, I need to get positive and negative of the same thing. That's what I'm looking for there, is positive and negative of the same thing. I have the same thing, but I need one of them to be negative. Well, I could get a negative, okay? So I've got 2, but I want to get a -2. That's what I want. I could get that if I multiplied by -1. Okay, that would work. So what I'm going to do, I'm going to pick one of those equations, it doesn't matter which one, and I'm going to multiply it by a -1. Make sure when you multiply by -1, you multiply everything by -1. You can't just multiply pieces of it by -1. If you're going to multiply by -1, and to keep it balanced, everything's got to be multiplied. So the top equation in this case, I'm not doing anything with the top equation, and that's fine. You don't have to do anything with the top one. On the bottom one, I'm going to multiply everything by -1. So -1 times 2 gives me -2. And that's what we wanted. That's that thinking step that we're going through. Like we wanted to get that. -1 times -x would give me a positive x. And -1 times 12 gives me -12. Now I can add them going down. 2y plus -2y is 0. 7x plus x is 8x. And then watch your sign numbers here. -4 plus -12. Okay, so channel Mr. Coakley, okay, my 8th grade Algebra 1 teacher. -4 plus -12. That's what you're doing there. That gives me -16. And now we can solve this equation. This is an equation that's okay to solve. I want to get x by itself. So we'll add 16 to both sides. 0 plus 16 is 16. And then we divide both sides by 8 and we get 2 is equal to x. Now, I wanted to illustrate that for a couple reasons. I already mentioned the fact that I want you to know that you don't have to line them up any particular way. I also want you to note the 0, okay? The 0 doesn't always disappear. It doesn't mean that you've done anything wrong. It's not this horrible, awful thing, okay? Like, you add going down, 2y plus -2y or 2y minus 2y, that's a 0. And write the 0. 0 is a number. It's nothing to be afraid of. Now we have that option. I can take the 2 and I can plug it in to either equation. I can plug the 2 in right here, or I can plug the 2 in right here, and I can solve for y. That's one of the options. Totally okay to do that. I think I am going to do it that way because I'm going to do one more example, and I'm going to make the example up on the fly, which means it's going to come out horrible. Now, you can plug it into either one. I'm like a little partial to this one, I think. So I think I'm going to plug it into that one. 2y equals negatives, I don't know why I said negative. 2y equals 7x minus 4. And we are going to plug in x is equal to 2. So we're going to put that in right there. And 2 times 7 is 14. 14 minus 4 is 10. And divide both sides by 2. And I get y is equal to 5. So here's my answer right there. So y is equal to 5 and x is equal to 2. Or if you wanted to put that in an ordered pair, it would be the 0.25. So that's one that illustrates a couple things about the 0 and about the lining them up. So for the last example, I'm actually going to make this up on the spot, which means that's always very dangerous to make stuff up on the spot, just saying. So it could come out really horrible. I'm kind of hoping it does because I want to show you one more thing about solving these. So I'm going to do 3x minus 4y equals 5. And then I'm going to do 5x minus, I don't know, 3y equals 12. Okay. So this is one, the only good thing about this particular problem is that they're lined up. That's it. Like they're lined up. So the X's are lined up, the Y's are lined up, the equals are lined up, and the constants are lined up. So we don't have to do what we did in this problem here where we had to like reshuffle the equations around. What's bad about this is that I do not have any clear choice about what to multiply by to get things eliminated. So we just have to commit to something. You say, I'm going to try to get rid of the X's or the Y's. There's no clear-cut choice in this one. So let's just say we're going to try to eliminate the X just because it comes first in the alphabet, okay? We just have to make a decision. Nothing right or wrong about like which one we choose. So what I have here is I have 3x and 5x. I want to get the same number but opposite signs. I want to get plus and minus of the same thing. I don't have anything great to work with. So when you see a situation like this, it means you actually have to multiply both of the equations, okay? So this is, if you think back to the steps, it was multiply one or both equations as needed. In order to make the best decision here, what you want to be able to do is find the least common multiple between the 3 and the 5. But you don't have to have the least common multiple, so I'm not going to harp on that. I'm just going to tell you what's going to work all the time. If you take the top equation and you multiply it by the number on the bottom. So remember, we're focusing on the x's here. So if you take the 3x and you multiply it by whatever the coefficient of that is, and then take the bottom equation and multiply it by whatever the number on the top was, it will always, always work. It might not give you the smallest numbers. You might have numbers that are bigger than what you actually want, but it'll work and you don't have to think too hard about it. Now, the other thing I need to deal with is I need to have one of these be a negative. And so if I multiply these, I'll get 15 and I'll get 15, but one of them needs to be a negative 15. It doesn't matter which one is a negative 15. You just need to make one of these negative. So I'm just going to go ahead and make the top one negative, but you could just as easily make the bottom one negative. Okay, let's multiply this. Negative 5 times 3x is negative 15x. That like freaks me out when that happens. Negative 5 times negative 4y is positive 20y. And then negative 5 times 5 is negative 25. And it would be good if I turned the pen back on. And for some reason, I feel like I got distracted in the middle of that, so I am going to just check my work there. Negative 5 times 3 is negative 15. Negative times a negative is a positive. Okay. All right. I feel okay about that. And now let's do the bottom one. So 3 times 5x is 15x. And that's what we wanted. This is what we were aiming for. We wanted plus and minus of the same thing. 3 times negative 3y is negative 9y. And then 3 times 12 is 36. And now I am okay to add. Now if I add them going straight down, we'll say like the x's are going to be eliminated. Negative 15x plus 15x is 0. 20y plus negative 9y is 11y. And then 36 plus negative 25 is 11. And I'm just kind of floored that I actually wrote a problem where the numbers came out nice. I was hoping they would come out awful. And out of the blue, I wrote a problem where the numbers came out nice. So, all right, and we go ahead and solve this. So y is equal to 1. Okay, I am going to do the second half of the problem differently, just because I do want to illustrate something. And had I known this problem was going to work, I would have done the whole beginning part of this lesson differently. But anyway, moving on. I'm not actually going to go and substitute this back in, okay? So we're just going to work the problem over again, and I'll show you what I mean by that. At the beginning of that problem, I made the kind of arbitrary decision to eliminate the x. And I didn't really have a great choice. I just said, let's eliminate the x. What if we had made the other decision and we said, let's try to eliminate the y? Okay, so now we're looking at this. And what we want is, again, the positive and the negative of the same number. And I don't have any great candidates there. What will always work, okay, remember this will always work. It might not be the most efficient way to solve the problem, but it will work. Take the top equation, multiply it by the bottom number. So I'm going to multiply that by 3. Okay, I'm taking the bottom number. And again, we're focusing on the y's this time because we made a different decision. Take the bottom equation, multiply it by the top number. It will give you a common multiple. It might not be the least common multiple, but you don't need the least one. Anyone will do. And remember, one of these has to be negative. So we have both of them being negative. I guess one of them needs to be positive. So I need to make sure one of these are negative. Last time I made the top one negative. So for this one, I'm just going to make the bottom one negative just to show that you can do it either way. Let's go ahead and multiply this through. 3 times 3x is 9x. And then 3 times negative 4y is negative 12y. And then 3 times 5 is 15. Moving across the bottom, negative 20 is what I'll get. Negative 4 times 5 is negative 20x. Negative 4 times negative 3y gives me positive 12y. And negative 4 times 12 is 48. Oh, negative 48. There we go. Now, this is what we were trying to get. Okay, remember we're looking for a positive and negative of the same thing. So negative 12y plus 12y, when you add that, you get 0. So let's go ahead and add going down. 9x plus negative 20x is negative 11x. And then these two end up canceling out. And then I have 15 plus negative 48. And that is negative 33. You don't need to write the plus 0, okay? You just don't need to write that. Divide both sides by negative 11, and we get x is equal to 3. So what this is illustrating here is that you don't have to do substitution. You can actually repeat the process. So for those of you that get really good at doing this, instead of doing this, where you go and you plug the number in and find the other value, which is totally fine to do, you can actually pick one where you eliminate one variable and then just repeat the process and eliminate the other variable. This is especially nice if you get a really awful number here. Like last class, we had one that came out to 32 over 7. And you might just say, I don't want to do anything with that 32 over 7. I would just rather repeat the process and have this work out this way. So this ends up being the 0.31. And it's very weird and very rare that I would make up a problem and actually have the answer come out that nice. I'm a little disappointed. So that is everything that you ever wanted to know about elimination. Last little piece of notes here is when should you use the elimination strategy? So we talked about when should you use substitution. When should you use elimination? So when should you use the elimination method? Typically you'll use the elimination method when equations are in standard form. That's your ax plus by equals c. Most of the ones that we've been looking at in the last 2 lessons have been in standard form. And when opposites are already there or they're easy to get, is kind of what you want to keep your eye on. I would say anytime substitution isn't a good method, probably you're going to use elimination. Just be prepared. You got to do that thinking step. You got to think, what do I want to get? And then how do I get there from here? So the next thing that you guys have is to get some practice. So we're going to take the rest of this class period. I'm going to put some practice problems up here, and then you are going to work those out, and maybe we'll share them and we'll talk about them. It depends on whether we're online or face-to-face, just how we'll handle that. So here they are. The first two are pretty simple. I don't see those giving you guys a hard time. The third one, though, let's take a closer look at the third one. The third one is not lined up, and so you do have to do a little bit of juggling to get the third one lined up. The third one is actually better maybe suited to substitution because you have one of the variables by itself. But I don't want you to use substitution. The goal of this lesson is to practice with elimination. You'll also notice that I have the answers on the right-hand side there. That is not so you can read off my own answer to me. That is so that you can check your work and know if you're getting it right without feeling like you have to raise your hand or unmute yourself and ask a question or whatnot. So in your notebooks, take some time, work these problems out, see if you get those answers, and then we'll go over them together.